Okay guys, so this is the Tan-Chord theorem. They are saying to me that I must prove that the theorem which states that MNQ, that's MNQ, this angle here, equals to K. So that is what the Tan-Chord theorem say. So now you must check, highlight the chord that is in equation. This is the chord. This is the chord that you must, because it's an angle between this chord and this tangent here, right? So you must highlight the chord first, and then the second thing that you need to do, you must make sure that you draw a butterfly theorem inside, such that this chord will subtend the angle. So this is me drawing it. It must pass through the center. I'm drawing that. It must be subtended by that same chord that you are trying to prove that this equals to this. So you can see that butterfly holds this equals to this, right? So that is the intention. You need to make sure that the chord in equation is such that if, for example, maybe they had said, I need to clarify this, guys. If this was the case, you have this here, you have that, you have that, you have that. If they said prove that this equals to that, you're gonna highlight the chord. This is the chord in equation, and then this is the center. So you're going to make sure that you draw a butterfly such that this angle is also subtended by the same chord that you're trying to prove. Right, that is the trick number one that you need to make sure you master it. So we can name this angle here maybe G, or whatever letter that you feel comfortable with. All right, and then maybe we can say this is our N1 and this is our N2. So we want to make sure that the intention is to show that N2 equals to K. That is what we want to prove. All right, so now the first thing that you're gonna say is to say that construct you construct diameter, because it must pass through the center, diameter ng. You construct diameter ng and join GM. All right, so there's a mark for construction. You construct ng and join GM, and then afterwards what you do is you're gonna say that N1 plus N2 plus N2 equals to 90 degrees. You can see by yourself that this is a diameter, same as a radius and a chord. We know that a radius is perpendicular to the chord, right? So the angle between the radius and the tangent, not the chord, the angle between the radius and the tangent is always 90 degrees. So that's the reason it's gonna be 10 perpendicular to chord. All right, and then we're gonna make sure that we write this in terms of N2. Remember, this is what we want to prove in terms of N2. So from this you can say N2 equals to 90 minus N1, right? So we're gonna use this somewhere else. We have proved that N2 equals to 90 minus N1. So the next goal is to prove that N2 equals to G, because G is equals to K, angles on the same segment. So if we can prove that this N2 that we've just shown that is 90 minus N1, if we can prove that it's equals to this angle G, then we can conclude that since G equals to K, then K equals to N2, right? So you can see already we are not far. So this angle G that I'm trying to prove that it's equals to this, all right, it's in triangle. I'm going to just highlight the triangle where it is in this triangle, and this is the diameter. And we already know, me and you know, that in that triangle, angle M GMN, this angle here, it's 90 degrees because this is a diameter. It's an angle at semicircle. So GMN is 90 degrees. So angle GMN equals to 90 degrees. Y, angle at semicircle. All right. So now, if that is the case, then we know that this in the same triangle, this plus this plus this equals to 180 degrees. So N1 plus G plus M. Let's say N1 plus G plus M equals to 180 degrees, sum of angles in a triangle. So you can see that in this triangle, this plus this plus this, they gave us 180. So we're gonna make sure that we write everything in terms of G. We make G the subject of formula, and we already know that our M is 90 degrees. We've just said that. So N1 plus G plus our M, which is 90 degrees, equals to 180. Then now I want G to be alone, so I'm going to say 180 minus 90 minus N1. So that is 180 minus 90 is 90 minus N1. That is our angle G. So already you can see that this is the same as this. That means N2, as we have shown, is 90 minus N1. Also G is 90 minus N1. So basically, I have proved that this equals to this. Alright, so now I'm concluding. I'm going to say G equals to K, because that is true. G equals to K. Why? Angles at same segment, right? Angles at same segment, because they are supported by that same chord. Therefore, if this is these two are equal, that means K equals to 90 minus N1. So that means this and this are proved to be equal. So N2, therefore N2 equals to K. And I'm done proving the theorem. Thank you so much, guys. My name is Thapelo.